So welcome to the workshop. This demonstration video today is on the manual lathe. So we refer to your student handbook. You can get this diagram in your handbook, naming all the parts of the lathe. This matches the lathe we have in the workshop. It's a Cholchester Harrison M300. This is 100 group. And the main components of that lathe you can see above: the chuck, the speed controls, headstock, chuck guard, chuck itself, the coolant, tool post, tailstock handle and lock, tailstock handle depth gauge, top slide, moving on the Z-axis, the saddle itself, the cross slide, the on-off lever, which is the favourite, the red handle down below, the lead screw cutting feed handle, the automatic feed handle starting up and down, the apron, the carriage handle on the Z-axis, the emergency stop switch or high-step switch to the machine itself, the coolant switch, the power control, feed controls. So let's have a look at the machine itself. So as we referred to those booklets, when you're always going to calculate the speeds for the first time, we've done this before in the previous notes on how to calculate the speed, the RPM for the lathe. And that's done by the formula. The RPM is done by 1000 times S over pi times D. S sometimes known as BC, and that depends on the material you're cutting and the type of material of the tool you're cutting with. So the material you're cutting and the type of cutting tool gives you your calculation value for your S. So the work diameter then, if you're turning down, that is the work diameter is your D value, and then if you're drilling, the D becomes the drill bit diameter. This is all in your booklet, and then to refer from that, we can see a slide example down here of actually calculating out the RPM for various different cutting speeds. So there's an example there, calculating the RPM for a work diameter of 25, work diameter of 30, and a work diameter of 24 millimeters versus 18. And we can see the smaller the diameter of the material, the faster the RPM is increasing. And then the RPM affects your feed rate, as in the formula, the RPM that we can see here, the feed rate is equal to the N times F, which is the feed per tooth, times the number of cutting teeth on tool, normally being one on the lathe. So let's look at the lathe. Start off with the main controls. We have down here the power, coolant, and the isolator switch. That's just stops power to the machine, and the machine can't be operated while that's on, while that's engaged. So that will only isolate power. That's not how you generally stop the machine. It's only an emergency situation when you press that button. So you twist that to remove it up. So this is what's called the carriage moving down the Z-axis. We've got a DRO up here, so we can reference this point at any stage by pressing the corresponding button for the Z. Allows us to store a set position and move then in increments down, and that's in millimeters, 19 points, up to 1 micron of accuracy. The X-axis is controlled going across the slide. That controls the X-axis. So by pressing the X button and 0 and enter, we can move from a set position and reduce down the diameter of the material. So to start and stop the machine, it's done by the lever here, by putting it out and down. But the machine will not start or stop, or it will not start unless the chuck cover is in place. So back here we have the tailstock lock. We're first of all going to look at how to set the RPM, and according to that, using that example there, of those 3 examples, let's look at setting those RPM values. So they are for a diameter at the speed of 265. As we go to our lathe, we see we haven't got 265, so the closest value we have to that is 260. So to set that RPM speed, this selector needs to be moving up along in that position, and then you need to move this selector into this column to highlight that box of 260. So to do that, what we're going to do is, if you find it difficult to rotate the chuck at that low speed, you can use your chuck key to help you get some leverage to help your rotation. So you press in and rotate, and it's a gearbox. So we always set the speed on the lathe when the machine is stationary. So we rotate around and we're in position. So now we've selected the 260 RPM. So it's in gear. I can feel it in gear there now, I promise. On the chuck key, this is a self-centering 3-jaw chuck. So as you rotate in, all 3 jaws are coming in 120 degrees phase apart from each other and will close into the center. So you put your material in here for gripping. If you want to put your material inside, that is going to be your diameter 25 material, according to our formula. We're popping that into position. So we're going to set RPM for turning that down. So we'll have a material in position, and we'll slide overhang there of approximately 30 millimeters. So I'm putting my chuck key back into its holder. And now to start the machine for the very first time, making sure we can operate it safely. We're away from it with no cutting tool in place. We're just going to start and stop the machine for the very first time. So we're pulling this lever out and down to start, and that's travelling then clockwise. The material is coming onto the tool, it goes here at 260 RPM. To stop the machine safely, lift it out and up, and it stops stationary. There's an emergency stop brake underneath, but generally you're never going to let the machine come to a stop on its own. If you move out and up, that's going into reverse. 90% of the time you're always travelling, always machining down, with the machine out and down, all the work turned onto the tool and we're cutting. So now let's look at the next stage. We'll be installing a cutting tool. So we have a range of cutting tools up here. We have got a turning tool, which is done for your facing and turning down the diameter of a bar. So to face off, we can machine across in this position, and to turn down, we're coming along the Z-axis down on the carriage to reduce down the length of the bar. So to reduce down the diameter, you're moving in the X position, and to reduce down the length, you're moving in the Z position. That's what we call carbide cutter, and that's for doing a 45-degree chamfers on the chamfer of the part. This tool here is what's called a parting off tool, and that's used for cutting grooves into the part. So to put a tool into the first time, and this one is just a difference in it. That's high-speed CR tool steel, different material completely to the carbide cutters. So I'm going to install the tool for the first time, and to do that, we're going to need to get the tool holder. So these are the tool holders. They come 3 in a set. We have one currently on the machine, but that fits into the tool. The tool fits into the holder, and then you take your key, and you tighten down those 4 bolts securely. Now to install this into the tool post, again for all the names that we're talking through, refer back to the manual that were previously shown in the video. So to slot this in position, it would slide in that position there for starting the machine. But we first now need to set the tool height on center of the revolving tool. So to do that, this is the revolving center using for setting up the tool heights. So to pop that in, this is what's called the tailstock. This is the tailstock handle at the back. This is the quill lock, which stops you from drilling. So you're going to leave that open. And this is the lock used when you put on when you want to drill. So to put in the tool, you need to wind forward the distance between 50 and 60 millimeters, because this is a Morris taper effect to fit into the tailstock. It slots in, and to remove it out at any stage, you just wind it back and it will pop out. So to put it in, you have to ensure that it's wound forward in order to install. And the distance you have to move in about with your hand, which is again 56 millimeters. So now we're going to set the tool height. And this is a vital step at the very start. Every single tool that goes into the machine needs to check the tool height on center. And this will ensure you get a good finish on your part, a good surface finish on your quality. So you're checking that the tool height is on center, and if you need to adjust it up and down, you open the lock and you lower and tighten. Allow for it to kick up as you tighten the handle, it will adjust up, and that's perfectly on center now if we're looking for it. So that would stop it from allow us to get a good finish on the part. So the tool is set up in height. I'm going to move it now in for to face off the part. So now we've locked in position. We want to now bring it over, and then the coolant always gets put onto the tool and not onto the work. I'm going to leave it away for a second and turn it off, just to set you see that's how you set the 0 point in our Z. So that's our Z, the tool is touching the work, and we can go here and set our Z reference to 0. So that will allow us to travel. If we wanted to move down along, we can then see if we want to reduce down the length by 5 millimeters, that would bring it down by 5. And to reduce down the X, the diameter of the bar, you touch the tool off the work, 0 the X, and enter. So that allows us then, we're controlling here, as we go, we're now reducing down the diameter. If I as we adjust in here in the cross slide to 0. Now we'll take it down by 1 millimeter. So power on our lathe now. We just want to face across the piece for the first time. I'm going to face about 0.2 of a cut. And I'm just facing across the material manually. So I'm manually facing across and I'm just adjusting here and I'm feeding between my hands. What we're trying to ensure here is we're getting a nice, making sure we don't have a pip at the center point. And then that's done, moving it back away. So now, stopping the lathe for the first time. To use automatic feed, what we have here is this lever in this direction changes direction. When pushed in, you're controlling, it'll travel down in the Z-axis. When pulled out, you'll travel across in the X-axis. So when pulled out, we're going to face off the piece. And then our feed rate is set here by these 4 levers in control. So A, T, X, 8 tells us we're going at a pitch there, AT8X of 0.2. So the formula is the RPM, 260 is the RPM, times 0.2 times, you've only got 1 cutting tooth. That gives us the distance, how fast we're traveling. So 0.2 times 260 will give us the feed rate. So if you increase the RPM by holding the same feed, the same gear chain, it will obviously go faster. If you increase up to 200, 1200, it will go faster in the feed, automatic feed. So powering on the machine, just to show you how automatic feed working. Engaging the lever now, and it's automatically machining across facing the part. We're going nice and slowly just for this video purposes. And you can see the difference, we're getting a nice continuous chip by doing it automatically versus doing it manually. You're going to have a nice continuous chip and a better finish generally on the parts when done using automatic feed. That's it, kind of the facing off procedure. And you always stop the automatic feed and then stop your machine. Never leave the automatic feed engaged and stop the machine. That will prevent any accidents. So now if you want to turn down the diameter, we have our X set. X is put to 0. X 0. 2 is touching the work. And you want to reduce down the diameter by 1 millimeter. We adjust into 1 millimeter. Power on your machine, and you're traveling down in the X-axis, in the Z-axis now, and you're reducing down the diameter of the work. You want to avoid doing this fast movement. That'll give you a very bad finish, you can consistently see. And then what you want to do is nice continuous feed to get a continuous chip coming off the work. So we can clearly see here, if we don't have a continuous feed coming off, we get a very bad finish that we did here. The jerking. So to use automatic feed, you're going to push in the lever here. When that lever is pressed in, that'll cause us to go down to the Z-axis. Then pulling up the automatic feed, we now have got automatic feed traveling down in the Z-axis. So you're automatically machining the Z-axis. So to get a good finish, it's really important to have the tool height on center, and then have the correct speed and feed calculated out according to that tool you're using and the material. So I'm going to stop that there now. That's the basic principles of setting your X and your Z axis. Now for drilling purposes, here we have this. We want to move out your revolving center. And you've got a range of tools here in your chuck. So this is a Morse tapered chuck, and that is used for holding drill bits with a straight shank up to the parallel shank up to size diameter 13 can be put into this normal chuck. So to put a chuck in, it's the same way. You need to wind forward to slot it in, 50-60 millimeters, and then it just clicks into place. And then you can install your center drill bit. It's used first for drilling a hole, a pilot hole, before you use your drill bit. The angle of your center drill bit is 120 degrees angle, and that also matches the angle here of your revolving center, 120 degrees, allowing you, if you want to support the work in your part. So to use the center drill bit for the first time, you pop it into the chuck, tighten it up. I'm going to increase the speed for that up now to 800 RPM. So to do that, again, I need to twist the lever over and then move this selector along this column here to highlight the 800 box. So I'm rotating the chuck and twisting the lever at the same time to get me into the gear of 800. So I'm in position. I'm going to move the turning tool out of the way. I want to center drill a small hole here for a pilot hole. So I push forward the chuck, and now we're looking at the coolant for the very first time. So the coolant gets applied onto the tool and not onto the work. So the lever for the coolant is located down here, and you adjust your flow rate on your coolant is out here. Now adjust your flow rate. You don't want a big flood of material, just a nice drip constantly onto the part. Pause. Preparing on our lathe, and now we're applying the coolant onto the. So to make sure now is we have the lock on for our tailstock, and you're drilling forward. If you don't have the lock on, what happens is when you drill forward, the tailstock will move back. So ensure the lock is pressed on, and leave this quill lock off because that's stopping it from drilling. And you're drilling in so you create that cone shape on your part. So you're drilling in there so you create that kind of a cone shape on your part. Now what that allows us to do then is we can remove out this chuck, and if we like then you can continue on if you wanted to drill larger holes. We can see there that for the larger drill bits they have their own what's known as a sleeve, and that's for fitting in here to the tailstock with the larger size drill bits. So drill bits up to size 13 in diameter fit into the chuck, and after that then the larger drill bits 14, 15, 16, 17, 18, 20 have their own sleeve. So now we can pop the revolving center. So another use of the revolving center is support work. So supporting work, what I mean by that is that we're going to be able to extend the work out now. Because we've got a central, we allow us to extend the bar out from the chuck, and it's very important that you always support the work when extended out more than 3 times its diameter. So meaning that if the bar is 20, once it goes past 60 millimeters of an overhang, you have to support the work, otherwise it'll be oscillating up and down. So by supporting the work, what we can do is push in the tailstock and get set up here by adjusting it out, again 60 millimeters of a distance to ensure everything it moves freely. So you apply on your lock in the tailstock, and now what you want to happen here at the end of the video is we can now turn down that diameter of the bar the full length. We can find our 0 reference point back here, touch the tool off the end of the piece, 0 or Z, come out to the outside, touch the tool off the outside of the bar, 0 or X, and we can reduce down the diameter of that bar to suit accordingly to our drawings. But now what you want to see when you turn on the machine is you want to see that you want to ensure that the revolving center is rotating with the work, and that it's not like this, it's not rotating. So it's not rotating, then it's not supporting the work, therefore it's going to be oscillating up and down. So ensure that it's fully engaged, and when it's fully engaged, then you apply on your quill lock to support the revolving center, keeping it a lot steadier. That's in that instance. So now that allows us that part of the video. So we can now have done our RPM, our feeds, gone through our coolant, and in the instance of emergency stop, that if you were powering on the machine and if something had happened, that you could hit this emergency stop at a time and it automatically kills power to the machine. That's not how you generally stop the machine, but that's an emergency stop. So to start the machine again, that needs to be freed up, and then that allows the machine back on again. So to stop and start the machine safely, it's out and up, and it can bring to a halt and break underneath. Finally, at the end of class, it's always important to clean down afterwards, and when you're finishing up your part, to always remove back the tailstock, back to the very end, moving your carriage back to the end. Give all the tools you got from the store back into the store, clear up your area there, and put the tools back into its holder, and clean down inside the slides, and removing all the material away from the sides, making sure it's clean and ready for the next student, and to sanitize your area before moving on to the next area. remove your work and store it in your lockers as provided. And please refer to the next set of videos for your projects.